The new section is entitled Inscribed and Circumscribed Polygons. If you have a circle and you put the polygon inside, whether it's a three-sided figure, three-sided polygon, or 2, 3, 4, 5-sided polygon, these are inscribed polygons, because the polygons are inside the circles. These are inscribed polygons. What if we put the polygons outside? This one here, or this one there. These are called circumference, as in circumference. Actually, they're called circumscribed polygons. Now, of course, you can talk about the circle being circumscribed. This one here, you have a polygon and the circle is outside. This is a circumscribed circle, because the circle is outside. If you're outside, whether you're a circle or a polygon, you are circumscribed. Here, the circle is outside, so the circle is circumscribed. So circumscribed circle. Here, and here, of course, the polygon is outside of the circle. So we call it a circumscribed polygon. Don't recall ever hearing this, but we can call this an inscribed circle. What is it inscribed of? It's inscribed of a polygon. Okay, so whatever is outside is circumscribed. Whatever is inside is inscribed. And the its are either circles or polygons, at least for this section. So let's get right into our theorems. This time, if we have a quadrilateral, a four-sided figure, and it is inscribed a circle, then the opposite angles must add up to 180. They must be supplementary. So if a quadrilateral, which is simply a four-sided polygon, is inscribed quadrilateral, is inscribed the circle, then the opposite sides, so D, the opposite sides, the opposite angles, the opposite angles are supplementary. That is, they add up to 180 degrees. Okay, and why is that? Well, you have you have a circle, and you have any old four-sided figure. And of course, the circle has a center. Let's call this quadrilateral A, B, C, and D. And angle A and C are opposites, and for the record, B and D are opposite. Well, angle B cuts off or intercepts, cuts off arc, so angle B, it cuts off arc AC. Cuts off arc ADC. Angle D, on the other hand, it cuts off a different arc. Angle D is this angle, and it cut off this arc. ABC cuts off arc ABC. Okay. But the red marks and the black marks, they don't intersect, they don't overlap, but they cut off the whole circle. They cut off the whole circle. Now, remember, the measure of angle B is 1/2 the measure of arc ADC. And the measure of angle D is 1/2 of its intercepted arc, namely arc ABC. Well, I add the left sides. I get the measure of angle B plus the measure of angle D. I add up the right sides. I can factor out the half. I get 1/2 the measure of arc ADC plus the measure of arc ABC. But, like I said, those two arcs, they add up to 180. Sorry, 360, the whole circle. They add up to 360 degrees, the arc. And half of 360 is 180. Well, that's what I wanted to show. The measure of B and D, they add up to 180. And since B and D were arbitrary angles on this, they're just any old opposite angles, it's going to turn out that angle A plus C, it's going to turn out that A plus C is also going to have the same result. And the reason is angle A cuts off this arc right here. Angle A cuts off that arc. And angle C is made up from these two rays, and it cuts off this angle. Well, the green and the red, just like in the last problem, they make up the whole circle and they don't overlap. They make up the whole circle. So, once again, those two arcs add up to 360. And the measure of A was half of the red arc. The measure of C was half of the green arc. So the measure of A plus C must be half of the green arc plus half of the red arc, which is half of the arc of the whole circle. That is half of 360, which is 180. So angle A and C are supplementary. Once you find out that angle B plus D or angle A plus C add up to 180 degrees, you say, oh, you mean they're supplementary? That is the definition of supplementary. That any four-sided figure inscribed in a circle, opposite angles, 180 degrees. You have any circle and you have absolutely any four-sided figure. This angle and that angle, 180. They add up to 180. This big angle, excuse me, and this smaller angle, they're not equal, but they surely add up to 180. The reason is, these opposite angles, they cut off the whole circle. This angle right here, made up of these two rays, and basically, just ignore everything else if it's bothering you. That arc, this angle cuts off this arc. And let's put back the rest. This angle here goes from here to there. It cut off the remaining part of the arc for the whole circle. Those two arcs cut off 360 degrees. And there's no overlapping. So the angles must add up to 360. Okay, so now we have another theorem. If a parallelogram is inscribed, a circle is inscribed a circle, then this parallelogram, that's the symbol for parallelogram, must be a rectangle. There is no way around it. It must be a rectangle. So you have a circle and you have a parallelogram inscribed. So this line and this line. Well, it couldn't be that line. Actually, let's try to make the circle round first of all. If you have that perfectly round circle and then it didn't show up. If you have this circle, and you have this arc, and this arc are parallel, and this arc are parallel, what's inside is a rectangle. Now if you want to say, looks like a square to me, fair enough. So I won't deal with this diagram, but let's make this line pretty short and up here parallel. So these two are also parallel in the same length. Well, they're parallel. This line parallel. This line and this line are parallel. Clearly not a square. So no, it's not always a square. So now, in fact, I think I even want a bigger circle to prove the theorem. Boom. Okay, so I got rid of it electronically. Let me erase it from my physical board. Okay, so now we have this big circle, and we have this line and this line parallel, and this line and that line parallel. Now, I claim that this must be a rectangle. Okay, so that's what's given, what's in black. I draw my transversal. Now, if you want, you can think of these sides going as long as you like. But remember me and the z's. I see a z right here, which means these angles inside are equal. And if I draw my z the other way, then these two angles are equal. And for the exact same argument, these two angles are equal, and the same for these two angles. Why are their angles 3's equal? Because of this z. And remember, these are parallel. Okay, so we have that. Now, whatever this angle is, this angle must be the sum of those. That must be 3 plus 4. And opposite angles are equal, so that's 3 plus 4. And whatever that angle is, whatever this angle is, this angle here must be 2 plus 1, or 1 plus 2. 1 plus 2. All right. Now we have 4 triangles. 1, 2, 3, and 4. Well, 2 and 3, they have the exact same angles. So does triangle 1 and 4. They have their exact same angles. So 1 and 3, if I can use opposite triangles, they are similar. They are proportional. But now, let us look at it from a different point of view. Let us look at it with respect to the arcs that are cut off. Let us look at that. So, you have A, B, C, and D. So, A, B, C, and D. Now, we know that that angle is 180. Now, we don't know that it's crossing the center. Now, remember our little theorem. Angle 1 and angle 2. Well, they're actually both angle 1. The average of these two arcs should be angle 1. If this arc is 20 degrees and this one is 100 degrees, you add them up, you get 120. That means each of these angles are 60 degrees. Okay. Now, we know that both of those angles are actually the same. Okay, well, let's see what I'm trying to say. So, if this arc if this portion is x, well, let me not say it that way. If the whole arc is x and this whole arc is y, then we have that x plus y over 2 is 180 degrees. X plus y over 2 is 180. Okay, let us get rid of this. Actually, it's a shame, but let us get rid of this. Now, we really do have this, and we have this, and we have this at angle 1, and this was 1, and we have 2 and 2, and 3 and 3, and 4 and 4. Okay. Now, what if I divide it differently? What if I call this V and I call this W? They add up to the whole circle, 360 degrees. But more importantly, maybe that's just enough. Okay, so we know that this angle and this angle are equal. In fact, they both equal 180. So the intercepted arcs, when you add them up and divide it by 2, you get 180. That is, V plus W is 360, and down here, X plus Y is 360. Because only 360 divided by 2 is 180. Okay, so now, how do we go from here? That is the key question. Okay, first let me put the circle back so you guys can see this. So, you know, this angle was 3 plus 4, this angle was 3 plus 4, these two angles were 1 plus 2. And all I know is these two are parallel and these two are parallel. Now, basically, I just want to get a right angle somewhere because it is possible, it is absolutely possible for these two lines to be parallel and for these two to be parallel, hence a parallelogram, but yet it's not a rectangle. They are not right angles. I just need to show that one of those corners is a right angle. Okay, I have it. I have it. We can scratch most of this. Sorry it took so long. Equal angles cut off equal arcs. Okay, so we have our circle. We have our inscribed four-sided figure. these two sides are parallel, these two sides are parallel. And then I cut them by transversals, this transversal and this transversal, and this angle are equal, and this angle and that angle are equal. And for the record, so are these, and so are these. Now, let us concentrate just on this angle. Let us just concentrate on that angle. In fact, okay, let us concentrate on that angle, which is made up of these two legs. Those two angles, sorry, well, yeah, 1 plus 4, those two angles, or that one big angle, it cut off the arc just highlighted. But you know what? This angle is the same. And it cut off this. They cut off both of those angles. The red and the green slashes is the whole circle. It's the whole circle. They must have each cut off 180-degree arcs. Now, just because it's the whole circle doesn't mean that they both cut off 180 degrees. But each. Okay, you know, one could have cut off, the green in theory could have cut off 210 degrees, and the red arc can only be 150 for a total of 360. But that's absurd in this case because the angles are both the same. So now we know that angle 1 plus angle 4 is half the measure of its intercepted arc. Less, maybe I'm using different letters now, but oh well. Angle B cut off. No, that's not true. Angle B cut off ADC, arc ADC. But we just argued that arc ADC is 180 degrees, and half of 180 is 90. Once I get one of these angles in parallelogram ABCD, once you know that you have a parallelogram, that is, opposite sides are parallel, and you have 190-degree angle, forget about it. They're all four right angles. You don't have to stress it out anymore. Okay. Now, there's a lot of so it is true that the only way you can have an inscribed parallelogram in a circle is to put a rectangle. That's the only way it's going to happen. No other way. Okay, you have to put in a rectangle. Now, what other consequences do we have here? So now we know if we put in a parallelogram, it is a rectangle. And you know that rectangles, the diagonals meet at the center, all four right angles. That is, okay, now we know that this angle, here we go again, and this angle are equal, this angle and this angle are equal, this angle and this one and this one. Okay, so now what do we know? Well, if this is a right angle, so triangle 1 and triangle 2 are the same. But more importantly, the diagonal BD and diagonal AC bisect in one another. That is, this length right here is equal to this length Oh, and not only do diagonals bisect each other in parallelograms that are same lengths. That is BD and AC, same lengths. So that means that AC got cut in half. Those four sides are the same. So now, in say triangle 1, I have two angles, one with one slash, angle 1 and the right angle, and with the side with one slash. Triangle number 2, it has a right angle, an angle called number 1, and the side in the middle is one slash. 1 and 2 are congruent. Okay, now I'm going to show that 3 and 4 are congruent. Well, triangle number 4, and I can argue it this way, triangle number 4, it has two sides with one slash, just like triangle number 3, and the angle in the middle are both right angles. That means triangles 3 and triangle 4 are congruent. But I want to show that 1 and 3 are congruent. That is, all 4 are congruent. And of course they are, because if you look at 1 and 3, let me put 1 here. It has two sides with one slash. The angle in the middle is a right angle. And triangles 3, it too has two sides with one slash and an angle in the middle. They are all 4 equal to one another. Okay. So they have 4 congruent triangles, and what you can say is the following. Okay, so now, just want to say it for the right reason. I want to call this point in the middle the center. And what properties does the center have? Well, if you have a line that cuts off exactly half the circle, that's a diameter. Remember, we argued that this arc is 180 and the other half is 180. That is, BD is a diameter. So here's one statement. BD is a diameter. Likewise, AC is a diameter. And wherever two diameters meet, it's a circle. If this is a diameter, that means the center lives somewhere on this line. And if this line is also a diameter, the center lives somewhere on this line. Since there's only one center, it must be where the two lines intersect. So now we know where the center is. And then you can say from O to A and O to B and O to C and O to D are radii of this circle. And since there's all these right angles, let's look at triangle number 1, for example. We can say the center is O. We can say OB squared plus OC squared is BC squared. We can say that for all 4 triangles. Now, we can look at, say, triangle 1 and 4 put together. Triangle 1 and 4 together. B, C, D. And for whatever it's worth, O is in the center. Well, this is a right triangle. So we can say that BC squared, this leg, plus that leg squared, CD or DC squared, is equal to the diameter squared. And we can say this a few times. There are 4 big triangles. 1 and 3 make one big triangle. 1 and 4 make one big triangle. 4 and 2 make a big triangle. We talked about 4 and 1. 2 and 3 make a big triangle. There's lots of theorems that we can state there. But the main one is, anytime you draw a parallelogram inside a circle, it is a rectangle. That is, opposite sides are equal, parallel, and you have a right angle. Okay, let's do a couple of problems, or a few problems, and that would be it. Let's suppose you have this circle. We draw an arbitrary 4-sided figure. You have a 100-degree angle here and a 60-degree angle there. And this is labeled, say, A, B, C, and D. And you are being asked to find the other 2 angles. Well, opposite angles add up to 180. If this is 60 up there, this angle down here must be 120. And if this angle up here is 100, you add 80 to get to 180. So that angle's there is 80. Opposite in a 4-sided inscribed polygon, inscribed in a circle. A 4-sided polygon is inscribed in a circle. Opposite angles add up to 180. Suppose you have this. You have a circle. You have some 4-sided figure inside it. And this time you are given some arcs. This arc, say, is 100 degrees. And maybe the other arc down here is 110 degrees. And we want to find the 4 angles inside. Well, this angle, it cut off 110 plus a 100-degree arc. It cut off 210-degree arc. So it must be half of that, 105. Okay. Now, since it is, so now what we know is, if this is 105, since it's a 4-sided inscribed polygon, the opposite angles add up to 180. So that's 75. As though it may not look like it, well, the 75-degree angle has these rays, and that arc, or maybe it does look it, that arc must be twice the 75 degrees. Okay, and the 3 arcs that make up this entire circle do add up to 360. For a moment I thought they didn't. Now, let us say look at this arc right here. This angle right here. It cut off this arc, which is 110 plus some more. Okay. Let's draw this up here. we have these three angles, or this four-sided polygon. 110-degree arc is this. 100-degree arc is this. And the balance of 150 is this. And this is 75 degrees, and this is 105 degrees. Okay, now, this angle right here cut off this big arc. Oh. Okay, this angle cut off here, that big arc. Okay, so my little problem in this diagram is, is 150 went out to here. So it cut off that arc. Well, let's break this arc into two pieces. The 100-degree piece, it's still 100 degrees. And I'll say from here to here is x. And I'll say from here to here is y. So this angle right here, it cut off 100 plus x. And when you divide it by 2, you get angle 1. Now, angle 2, it cut off that arc, part of which is 110, and the rest which is y. So now, 110 plus y over 2 is equal to angle 2. Okay, so now what do we know? So how are we going to find out what x and y are? That's the question to get this problem correct. Okay. So let us look at this circle a little bit differently now. We have these four sides. We have that's 100 degrees. And we have that this is x. And we have that this portion is y. And we have this portion over here to be 110 degrees. So we've always known that x plus y, we always knew that x plus y is 150. Okay, so now, how do we find out what y is? Okay, well, yeah, it's not so bad. I know that when I add 1 plus 2, since they're opposite angles, it's 180. Okay, so when I add the left side, since they have a common denominator, 100 plus 110 is 210, and I add the x plus the y. I add the x plus the y. This adds up to angle 1 plus angle 2, which is 180 degrees. That is, this numerator, 210 plus x plus y, is 360. So this must be 150. But we're going in circles, which is good, because I already knew that. I actually stated that a moment ago. From y all the way and y plus x, or x plus y, is 150. This is x up to here, and then I add on y. Well, I've always maintained that that was 150. Maybe you can't figure out the other two. Okay, maybe you can't figure out the other two. Now, I know the four angles inside add up to 360. Because if I cut it in half, I get two triangles. The four angles add up to 360. These two angles add up to 180. What do you add to 180? To get to 360 is 180. You know, I think I see maybe what I'm... So now, we know that angle 1 plus angle 2 add up to 180. So maybe this is going to give us our second equation. Here is in terms of x and y. Now, we know that angle 1... Sorry, I'm not seeing this immediately. We know that angle 1 is half. We know the measure of angle 1 is half of its intercepted arc. But the intercepted arc for angle 1 is 100 plus x. Is 100 plus x. And we know that the measure of angle 2 is 1/2 the measure of its intercepted arc, which is 110 plus y. And maybe this is what we said earlier. When you add the left sides, you get 180. Because the two angles are supplementary. When you add the right sides, you can factor out 1/2. Now I know angle 1 is wrong. I had 180 in my mind. It's 210 plus x plus y. Multiplying both sides by 2 tells us that there's 360. Here it's x plus y again. Is 210 plus x plus y. So x plus y should be 150. So I know I'm not doing anything wrong now. The thing is, let us try to convince ourselves that we don't have a unique four-sided figure. Let us prove that we do not have a unique four-sided figure. This here is 75 degrees, and it's inscribed or circle. Now, this is fixed. Now, the question is, No. Can I go like this and have a 105-degree angle? Can I also go like this and have a 105-degree angle? And notice that you get different angles for the other two sides. Look, the bottom line is, this must be 105. Of course, the opposites. There's no question there. Okay. But I didn't have, oops, let's try that again. The thing is I didn't have to put that point here. I could have put it over here. So, I'm not messing with these two sides. That guarantees me the 105-degree angle. Okay? So let me put this back in black, please. What I am messing with is where I put that fourth corner point. I'm going to put it here. That is, I go like this. Now, if you just look at the red, A, B, C, D, let's call this E. But if you look at A, B, C, D, A and C are opposites. That is, this must be 105 degrees. But in ABCD polygon, and D is touching the circle, sorry. In ABCD, you have angle B is that angle. But if you look at the black one, if you look at ABED, B is now a little bit bigger. Okay, so no, we cannot find out angle 1 and 2. We tried, but we couldn't. We're able to find the other two angles, but we couldn't find 1 and 2. All we can do is say that they added up to 150. That's the most we can say. They added up to 150. So, let us try another one. Again, you have a four-sided figure where two sides are equal. They're outright given equal. Side A, B, C, and D. You are told 110 degrees and 95 degrees. And you want to find angle C, angle B, the lengths of arc BC, and even AB, the arc of AB. You want the measure of these. Okay. Well, if you are given two angles so you have a quadrilateral inscribed in a circle. If you're not, and you're only given two angles, if they're not opposites, that is, they're adjacent, you've got all four angles now. Because if this is 110, that must be 70. If this is 95, this one is 85. Now opposite angles add up to 180. That is, they are supplementary. Now they are supplementary. Okay. So we have the measure of angle C. It is 70 degrees. We now have the measure of angle B. It is 85 degrees. Okay. Now, if in a triangle, if in a circle, or if in two congruent circles, two chords are congruent, like BC and CD, then I know that their intercepted arcs must be equal. Whatever they are, whatever arc BC is, whatever arc CD is, equal. Okay. So now, since I drew on this in my opinion, a lot. I wrote on it a lot. Let's just draw it again. We know these two are equal. This is C and D and A and B. 85, 110, 95, and good old 70. And we know that those two arcs are equal. Well, opposite 110, the arc cut off by the 110 angle is this arc right here. This angle A, the sides that made up A, they go from B to, they start at B and they start at D. So this arc is twice that. That arc is 220. But the arcs are equal. The arcs are both 110. The arcs are both 110. From B to C is 110. So BC is 110. Okay. Now we also want arc AB. Well, I look at arc AB and I see 2 points already there. They're made up. Oops, that's not true. Okay. Alright, so, sorry, AD. Angle AD is 70 degrees. So the arc that it cut off, namely BAD, is twice that. It's 140. So if I call AB, I already used up the letter X, so let me call it Y. If I call ABY, well then I get to call AD 140 minus Y. 140 minus Y is that arc. Those two red arcs, they add up to 140. Likewise, this is 85 degrees. Its intercepted arc is ADC. Okay. And that arc, I guess this is all we needed. This is kind of what we needed. Angle B is 85 degrees. So this arc opposite it must be 170, twice it. Okay, must be 170. Well, we've already used up 110. This must be 60. 140 minus 80 is 60. That is Y must be 80. Y must be 80 degrees. Arc BA, AB, 80 degrees. If you have 140 minus Y is positive 60, excuse me, you can switch these. The 140 stays. This positive 60 comes to the other side as negative 60, and the negative Y, which we hate because it's negative, goes to the other side as positive Y. And now we're done. Just subtract these two numbers, and now you know Y, which is 80. Okay, that finishes that problem. So, the big deal here is, like you know your name, like you know the times table, you have to know inscribed angle The arc opposite it is twice as big. You're given an arc, the inscribed angle is half the arc. Let us try another problem. You have a circle. This one has it all. You even have a line tangent to the circle. And you have a four-sided figure inside. A, B, C, D, point E, point F. And you were given the following. Angle B, the big A, it's 115 degrees. AD, 60 degrees. BC is parallel to EF. I think that's important in this problem, so let's make it look somewhat reasonable. That just moves point B over. Okay. And this is what's given. And we want to find ADC. ADC. We want to find angle CDF. Looking at the picture, I see I want to find angle C and angle A. Okay. Now, we're told 115 for angle B. That tells me immediately the angle, I have a four-sided figure, a four-sided polygon, inscribed the side of circle. That means the opposite angles have to add up. The two opposite angles must add up to 180 degrees. This angle here, 65 degrees. So does A and C add up to 180. Okay, now we're told that AD is 60 degrees. Now AD is not cut off by any particular angle. Okay. But now AC, angle B I meant to say, which is made up with AB and raised CB, this big angle is twice 115, it's 230. But as you can see, we know part of it. 230 minus 60 is 170. That is the other piece of this arc. Just CD. Just CD. Arc CD. It's 170 degrees. I'm just trying to list everything that I know. I mean, if I had this, then I can say that angle is 30. Why? Because it's opposite a 60-degree angle. But we don't know if we need that yet. In fact, I'll put it. Now, the one thing that I didn't do yet is use the fact that this this picture has a tangent chord. It has a tangent chord, or you have a line tangent to the circle. Now, what we know is the arc from A to B. The arc from A to B is half the angle of A. The arc from A to B is 1/2 angle B, excuse me, is 1/2 angle B. No, sorry. Half of the arc is equal to angle B. Now, I know my tangent arc. I have the tangent line, and right at the point of tangency, I have a chord. This angle is going to be half of this arc. That angle is 85 degrees. FDC, CDF. CDF is 85 degrees. Now, ADC. ADC. We have that one. 65 degrees. Angle C. Angle C. Okay. Show you how I'm going to get angle C. Well, actually, that won't work, what I was thinking. It's 30 degrees. And we also want angle A. Well, angle A. Okay. We know this is 30 degrees and this is 65. That used up 95. So this portion of A will be 85. Which we kind of knew. We can have gotten this from a different argument. Because this angle cut off that arc, which is 170 degrees. So it must be half of that. Now, let's see what we know. Okay. Since this angle is 65 degrees, the arc that it cut off must be twice it. Okay. And to make sure you're not making a mistake, 170 plus 60 is 230, plus 130 is 360, and those three arcs cover the whole entire circle. Okay. Now, if I call this angle X, that means that this arc would have to be 2x. And let's talk about the arc from A to B. We'll call this Y. Now, I know on one hand that 2x plus y must add up to the whole 130 degrees. And actually, let us call it 2y. Because then this would have to be y. And if I divide both sides by 2, I get x plus y should be 65 degrees, which makes total sense because when you add it to 115, you get 180. So let us think. So all we have to do is figure out what x and y are. Now, the one thing I have, here it is. The one thing I haven't dealt with is that BC and EF are parallel. Well, here is my Z. This angle and that angle should be the same. Well, 55 plus 30 give me the 85. So y must be 55, and what do you add to 55 to get 65? 10. Okay, so now angle A is x plus 85, but x is 10, plus 85 is 95. Angle C is y plus 30, but y is 55, plus 30 is 85. Now, just curious why this angle C is 85 and angle A is also 85. Now, that portion of A is 85. I don't know, it's called a coincidence. But nonetheless, I got everything. I use hardball techniques to get it. Okay, I use the rules that are given to me. I don't memorize, well, when I see this problem, I do this technique. That's not always going to work. From, here and there, they work, but not always. Okay, let's do one more. Okay. Suppose you have a circle and a four-sided figure. Inscribed. Four-sided polygon. Why do we keep having this? Because there are only two theorems here. And suppose that we call this angle right here 100 minus 2x degrees. And believe it or not, we call that angle x squared degrees. And we want to find the measure of this angle. This is very routine. Those two add up to 180. So x squared plus 100 minus 2x should add up to 180. If I take away 180 from both sides, the right side by design gave me 0. The left side I have x squared minus 2x minus 80. Okay, not 28, but like I said, 2x. Now, I would just love two numbers that multiply out to negative 80, but add up to negative 2. And those numbers I'm going to put right next to the x's. Numbers that multiply out to negative 80 but add up to negative 2. And you can have negative 1 and 80, negative 2 and 40, negative 4 and 20, negative 5 and 16. 6 doesn't go in, 7 doesn't, 8 goes in. And those are the two numbers that that add up to negative 2. They add up to negative 2. So negative 8 and negative 20 go here, except it's not 20 and it's not negative. It's positive 10, I meant to say. Negative 8 and positive 10. And you have a product of two numbers that equals 0. Remember, if you plug in a number for x, if you plug in 10 for x, let's try 11. Plug in 11 for x. That's going to be 3. And that's going to be 21. And you need to multiply these numbers. There's no symbol in between. Here, it means to multiply. You need to multiply. And the reason the answer isn't x equals 11, because when you multiply those two numbers, you don't get 0. One of these numbers have to be 0 for the product to be 0. When x is 8, this is 0. And that happens to be 18. But 0 times 18 is 0. If x is negative 10, this one's 0. And negative 10 minus 8 is a number. Excuse me. And if you multiply that number, which happens to be negative 18, by 0, you get 0. So mathematically, the answer to this equation is x is 8 or x is negative 10. Now, keep in mind that you can have one of the angles be a negative, and you can't have the angle to be more than 180 either. So, let's try 8. If x is 8, you square it, get 64 degrees. If x is 8, that's 16. 100 minus 16 is 84 degrees. And these two angles only add up to 148. So I'm just wondering why that would happen. How can that possibly be? Something is I want the two numbers to add up to negative 2. These two numbers add up to positive 2. Sorry. In fact, the first numbers should be positive, and the second numbers should have been negative. The second one's always being the larger number. So the big deal is this should be plus 8. And this should be negative 10. So x can be negative 8. Or 10 minus 10 is 0. So x can be 10. Now, if x is negative 8, this will be 64. And if x is negative 8, you'll be adding 16. You have 116. Now, what happened if I use 10? Well, if x, and these numbers, 64 and 116, they do add up to 180. But if x is 10, 10 squared is 100, and 2 10s are 20, and 100 take away 20 is 80. And 100 and 80, they add up to 180. So in this problem, you have two answers. Now, what you might want to say is the following, is that when you look at angle x squared, it doesn't even look like a 90-degree angle because it would have to be bigger for this to be 90. And this is clearly bigger than 90 degrees. Looks like if the angle only went up to here, it would be 90. So that is why I'm not going to keep the 80 and the 100. The two angles are 64 and 116. So upon visual inspection, I decided which of the two to keep and which of the ones to get rid of. This finishes this section on inscribed and circumscribed polygons.